Afternoon, everyone. It's a couple minutes past 2, so I think we will get started. Welcome to the PSC's Seminar Series on Environmental Change and Pacific Salmon Management, the view from both sides of the border. My name is Sarah Martin. I'm a stock assessment biologist with the Department of Fisheries and Oceans based out of Kamloops, and I'm a member of the Coho Technical Committee. I have the privilege of introducing our 28th seminar on the 2026 El Niño and State of the Columbia and Fraser River Fisheries. The format of today's seminar is slightly different as there will be 3 talks featuring speakers Dr. Guillaume Mauger, Shannon Conley, and Dr. Catherine Michielsens. Dr. Mauger is a research scientist at the University of Washington Climate Impacts Group. He is also the Washington State climatologist. Specializing in climate science, Guillaume works closely with communities across the Northwest to facilitate access to relevant climate science, to grow the region's capacity to use climate information, and to engage in collaborative, user-driven climate research. His research interests include methods for modeling and evaluating climate change impacts at local scales, hydrologic impacts of climate change, and climate change impacts and adaptation planning for resilient floodplain management in both coastal and riverine environments. Guillaume will be presenting on the status of the current El Niño event. Shannon Conley is the Columbia River Policy Analyst for the Washington Department of Fish and Wildlife. Here she serves as technical staff on intergovernmental agreements, cross-state collaborations, and river system forums. She currently sits on the U.S. versus Oregon Technical Advisory Committee, the Fish Passage Advisory Committee, and the Oregon Production Index Technical Team. Shannon will be providing some in-season U.S. fishery observations from the Columbia River. Dr. Catherine Michielsens joined the PSC in 2007 and currently serves as Director of Fisheries Management Science. She co-leads the Fisheries Management Division with the Director of Fisheries Management Programs. Catherine has a PhD in Fisheries Science from Imperial College, the University of London in the UK. Her main area of expertise is in the application of Bayesian methods for fisheries stock assessment. She worked 7 years in Europe on the assessment of Atlantic salmon stocks in the Baltic Sea before joining the PSC. At the PSC, her initial role was to integrate the various pieces of information and data on Fraser River sockeye and pink salmon within the in-season assessment framework, while accounting for risk and uncertainty when providing management advice. Since 2019, her role has focused on providing scientific supervision and leadership to Fisheries Management Division staff. Catherine will be sharing an update on the 2026 Canadian fisheries. Before I pass things over to the presenters, just a reminder on the format of today's seminar. The speakers will present back to back to back, and then we will have a moderated Q&A session. So please hold questions until after the final presentation, and then we can use the Q&A function to proceed with that. And another reminder that each seminar is recorded and made publicly available on the PSC website and YouTube channel. So if you know people who were interested in today's topic but were unable to join, the seminar will be uploaded and available online soon. And I think with that, I will turn things over to Dr. Mauger.
Thanks, Sarah. I'm assuming my screen's showing okay, like we tested. I think it is. We already
It
tested.
looks good.
Thank you. All right, just double checking. Okay. All right, well, I'm going to jump right in and make sure we have time for everybody's talk. And I'm going to start with the quintessential La Nina or El Nino slide, which is the sea surface temperature anomalies. Here we're just looking at the equatorial through northern Pacific. You can see circled in green there, that's the general El Nino region, that the anomalies are pretty large. One of the things that's unusual about this El Nino is that it's already emerged. Usually it's sort of now or later when we would start to see it, but we're actually in an El Nino now, as many of you know, probably from the news. And we have been in one for over a month now. So that's unusual. It's early emergence. The other circle there, and maybe that's a magenta color. I don't know what color that is. Sorry. Fuchsia. Those shows the warm anomalies off the west coast of the US. That is not necessarily always going to happen, but often something that we see during an El Nino emerging can be a consequence of both the changes in the winds as well as potentially a Kelvin wave propagation up the coast. Um, I want to note one thing. So I was saying the El Nino has emerged. We can see in the sea surface temperatures the signature, and so there probably are already impacts in the marine area. In terms of terrestrial influences and influences on our weather, El Nino and La Nina are both particularly important for winter weather and not nearly as important for summer conditions. So, to the extent that we want to understand how salmon are impacted with what happens in the terrestrial side of the equation, that's going to be more of a winter impact, and I'll talk about that in a moment. The other thing to note, of course, and I'm not being careful with my language up to now, is that we're talking about more likelihood on the terrestrial side of warmer conditions. But it's just loading the dice, right? We don't know until the winter unfolds exactly what we'll see. Whereas we know on the marine side what those conditions are, and we're seeing them here in this image. Okay, how has that evolved? Here's a quick animation of the last 2 months, actually almost 3 months, starting in late May through now. And you can see sort of the El Nino developing. You can see that actually equatorial Kelvin wave propagating, where we get colder water emerging over Indonesia, and the water and the anomalies increasing over time in the eastern tropical Pacific. You can also see off the west coast, there's a little bit of upwelling earlier in the season, and then those warm anomalies really set in coming into now. Okay, so the Climate Prediction Center at NOAA puts out forecasts. So this is a little different. Some of you, like me, may have previously looked more often at the Columbia forecast for El Nino, or maybe you're not looking at any of these. That would be understandable. Um, these Excuse me, sorry. So this is showing that forecast. These would show blue bars if there was any likelihood in the forecast of a La Nina, and gray bars if there was any. You can actually even barely see the potential neutral conditions in the January, February, March, and February, March, April. So these are 3 month averages. The bars are a forecast for different likelihoods of the sign of ENSO as well as the strength. The fact that the bars are almost universally pink through red says that we are 100% certain, essentially, all but 100% certain that we'll have an El Nino. Since we're already in one, we know that. And then that darkest bar, in the news a lot, there's been a lot of talk of a super El Nino. Although a super El Nino is not a technical term, strong and very strong are. So very strong means more than 2 degrees Celsius anomaly in that Niño 3.4 region. And we're in a place where that's a high likelihood, over 80% chance for October, November, December. That's what you're seeing for this middle bar, where the bulk of the likelihood is in that strongest. So we're very likely going to end up in an El Nino that's in the realm of the strongest ones we've seen, and potentially the strongest one that we've seen in the observational record. And then just to note, if we lump together the strong and very strong, we're up to 95% probably. So we know this is going to be a pretty significant event from the standpoint of the anomalies in the Niño 3.4 region. Finally, one more thing to note here, the oceans have been warming on average. If we weren't correcting for that, we would be falling into the El Nino category more often. This is actually a corrected index where they have removed that trend in order to specifically see what's the anomaly relative to the recent normals as opposed to the long. So we're not conflating that long-term warming trend with just a signature of El Nino overall, right? So that's what's known as the RONI. Like Rice-A-Roni stands for the Relative Oceanic Nino Index. And so that's what they're saying. It's relative there. They've subtracted out that long-term trend. Okay. Again, we're talking about sea surface temperature anomalies. We're not talking about sea surface temperature anomalies in our region necessarily, although they are correlated like we just saw. And in terms of terrestrial impacts, again, it's just loading the dice. We don't know what to expect, and I'll get into what the forecasts show in a moment. But first, just to note, like how anomalous things are, right? And so this is showing the annual cycle of sea surface temperatures in that Niño 3.4 region. This does not have the long-term average subtracted, so you are seeing both the long-term trend and the uh, El Niño La Niña cycles. That dark red line that's going off is this year, right? This plot was made through mid-August or early August, not all the way up to now. Um, no, one is that early emergence is very clear in this plot, right? None of the other, this is the only time in the record that temperatures have gotten this warm this early. So we're already in record territory in that respect. And even if temperatures stayed flat or didn't change much from here on out, there are very few occasions that have gotten this warm, even across all of the historical traces that you're seeing in gray. Okay, so pretty significant year in terms of those anomalies. Okay, I do want to talk about the terrestrial side of the impacts. I should admit I spend a lot of my time thinking about the hydrologic impacts on the climate and climate variability on the terrestrial side. Um, so that is a little bit where my expertise lies. I also think, of course, as we know, it's one piece of the puzzle for salmon. One thing I wanted to show this one. This is simply we call these postage stamp maps. I want to apologize. It's a lot of maps to stare at, but the thing that you need to know is this is showing every single El Nino sorted by strength from strongest in the upper left to weakest in the bottom right. Um, and then it's showing the precipitation anomaly, so the difference between normal for precipitation. When it's green, we had more precipitation than normal that winter. When it's brown, we had less than normal that winter. And so you can already see among the two strongest El Niños, we had opposite signs of precipitation anomalies. If you kind of try to average these by just scanning them, you see that there seems to be an inkling that the El Niños tend to be on the wetter side. There are more greens for the Northwest. I'm thinking about the Northwest here, than there are browns. But they certainly are exceptions that break that rule, and really significant ones like 76, 77, for instance. 04, 05 is probably one that folks might remember. Um, so all this to say, and maybe another way of saying that there is not a statistically significant association between precipitation, winter precipitation, and ENSO in our region. That's not true for other regions necessarily. The Southwest tends to be wetter during El Niños, whereas we do tend to be drier. The average is drier, but it's not a statistically significant effect. Okay. What is clear, and as many of you all know, probably in general, the global average temperature is higher during El Niños, right? We're basically bringing subsurface warmth heat to the surface, and that's affecting global average temperature on all as a whole. The distribution of that, of course, is not so simple, but in the Northwest, we follow the global trend, right? So the Northwest is warmer, and that is statistically significant during El Niños in general. Um, Again, that's an average. There are exceptions there too, but it's a statistically significant relationship. And that means that we can expect less rain, less snow, and more rain in those winters, right? So we tend to have worse snowpack as well that follows from the temperature anomalies in El Niño winters, which would suggest that we have a higher likelihood of heading into a snow drought, another snow drought, this coming winter and following summer. Um, just to illustrate that there are exceptions to this, last winter was a La Nina. It was a weak La Nina, barely qualified as La Nina, but still should have been better snow according to the averages. And it was actually an abysmal snow year in our region, really low snowpack all across the West, as a matter of fact. Okay, so what do we expect looking forward? So this is one set of forecasts from NOAA. This is for September, October, and November average. You're seeing the temperature anomalies on the left and the precipitation anomalies on the right. There is a strong agreement of warmer than normal temperatures for the Pacific Northwest and offshore for among models for that 3-month period. For precipitation, there seems to be over Washington an indication of drier conditions. Again, I would say that this is more uncertain than for temperature. If we look beyond to next winter, now we're really going far out in terms of the ability of the models to forecast this. And I think the way to look at this is that the models are really leaning heavily on the El Nino signature and what that tends to do in general or on average for temperature and precipitation. But they are consistent in that respect. They are suggesting warmer than normal anomalies. For the terrestrial side, the nearshore environment, the models are suggesting normal conditions, and drier on onshore, at least in the Northwest in that period as well. Again, I think that this is primarily just keyed to the long-term averages from previous El Ninos, so take it with a grain of salt. Okay, next. Okay. So far I've talked uniquely about El Nino. I do want to make a nod towards marine heat waves. Many of you probably remember the 2015 winter 2015 quote unquote blob, where offshore of our region, at least the sea surface temperature anomalies were at times in excess of 2 degrees Celsius and more. There's been a flurry of research since that time. In big picture, what I'm taking away from that literature is that the likelihood of marine heat waves, as in terms of big excursions from mean sea surface temperature, there's not a clear sense, and this is a difficult thing to model, of course, so research will be ongoing. Not a clear sense, though, that there's a link to warming there. But what's happening is that the background temperature is going up, and so we're going to exceed previous temperature records more regularly, simply because on average sea surface temperatures are warmer during marine heat waves as well as in general. And in fact, and that's what this slide shows, and I should have mentioned that first. Part of the reason the 2015 marine heat wave was so anomalous is because of that background warming trend, most likely. And I should mention also not much ability to forecast these. There's a little bit of predictability 6 to 12 months out, so similar to what we are able to do for El Nino, but they are also sort of limited in terms of our ability to predict them. All right, so just wanted to transition this funny comic, what does this all mean for salmon? And this is just by way of a quick segue to the following two talks. Of course, this audience, knows quite a bit, and we're going to hear from the experts in a moment from their talks. But I just wanted to very briefly, and again, partly because this speaks to both the oceanic and the terrestrial side, the marine and terrestrial sides, excuse me. But just, from a very simplistic sense, if when we look at this simple like life cycle diagram of salmon, if we think about the impacts of warming on salmon, they're essentially impacted across all stages of their life cycle. So just to spell it out, you know, we're going to expect to see bigger, and more frequent floods that could scour reds. It could also harm the 11s in their early stages of growth. We also expect earlier peak flows that could send juveniles out either into the lower estuaries or out to sea, before they're ready. So either physiologically or in their ability to avoid predators. We've got the warm low stream flow that everybody knows, and I think this is important, right? The most common water quality violation by far is water temperature, and this is a big one, as many of you all are well aware. And of course, what happens in the ocean. I hope we'll hear more about that in the next few talks. Not my area of expertise, so I'm being transparent here with the question marks, but we know that that is critically important given how few salmon that go out to sea end up returning to spawn. So I'll leave it there, and I did want to put up just two QR codes if folks have time or need it. If not, feel free to follow up and I can give you. But we do put out a monthly newsletter, and it will include, for instance, information on the El Nino status and uh, other aspects of our climate. Focus on Washington State. We also assess the water year each year. So are we in drought and why, and that sort of thing, and what does that mean for folks, including ecosystems? And that's the second QR code. All right, I will stop there. Thank you.
Okay, I'm assuming this is show. So, hi, I'm Shannon Conley. I am the policy analyst for the Columbia River Division with Washington Department of Fish and Wildlife. And today I'm going to present the 2026 Columbia River salmonids, abundances, and environmental conditions. Before this talk, I want to preface, as we just heard, we're not quite seeing a lot of those impacts terrestrially quite yet, which is a huge component of the Columbia River. But beginning, I did want to kind of look at what some of those contexts, looking at prior years where we've seen some of these same conditions we're seeing or predicting to see, to give folks kind of some understanding of what we may experience in the Columbia in the next year. So beginning with some temperatures, we are providing two different estimates of temperatures here, both the scroll case temperature at Bonneville Dam, as well as the Columbia River estuary temperature, which is provided by a buoy that CRITFIC, the Columbia River Intertribal Fishery Commission, really graciously has let us look into recently. Comparing to 2015, we saw some really similar temperatures in like May, June. Like our early spring was like really hot and concerning. So we were kind of gearing up for a bit of a worrisome late summer fall. But luckily, we started to see a lot of the temperatures actually revert back to that like 10-year average. And we've continued to see that trend over the last couple of weeks, which has been really encouraging at Bonneville Dam. Over at the estuary, you can see we saw that kind of start to track closer to that average. However, in late July and early August, we did see a spike up pretty intense. And currently we are decently under the average. So it's kind of where we're at temperature. So while we're doing okay with temperature, our flows aren't doing great. You know, there's a discussion of long-term water trends as well. However, you know, comparing to the recent average and the 2015 event, we're not in great shape right now. We have a super low flow year. And we can see that kind of in the daily flow at the dams. Kind of going to why that's the case. This was our snowpack back in January as compared to January 1st, 2015. We were in way worse shape this year with a lot of the middle Columbia and a lot of the Snake River, which feeds into the main stem Columbia. In some pretty dire straits as far as snowpack goes. And the upper Columbia was pretty awesome this year, but by April, you can see that we're in pretty bad shape with most of the Columbia and a lot of the upper Columbia and lower Snake looking pretty similar to what we were seeing in 2015 as well. Which brings us to what are we looking at drought-wise comparatively? We are doing better, which is nice. However, if you look specifically at that Snake River, which is where a lot of our endangered species are, it's in a pretty severe drought. So there's that. But the upper Columbia is looking somewhat good. So going into fish, why does this all matter? Water is super important for fish on the Columbia River. Obviously, both flows and temperature play a huge role in both outmigration, the fecundity of our fish, as well as travel mobility upwards. So, you know, as we go into warmer weather, but maybe more water, that could be helpful. But it really depends on accessing that snowpack for us. And so warmer and wetter is not always as helpful as wetter and colder. Looking into our spring and summer fisheries, our fisheries were mainly centered around spring Chinook due to low abundances in our summer Chinook and sockeye. It was a pretty tough year for us on the Columbia River. For the fisheries we were able to access, our recreational spring Chinook CPUE was 0.14, which was really great compared to that 5-year recent average. However, we do want to note that our catch abundances, our catch reports don't always reflect our abundances. We haven't found super high correlation between those two. So for spring Chinook, Bonneville Passage, which I will mainly be talking about our upper river fish because we have not done our run reconstruction yet, so we don't have a good understanding of below pond, but because we have a dam, our passage was around 107,500, which was the lowest in the last 5 years, but has been generally been pretty comparable, and it was 77% of the preseason forecasts, and it was rather significantly earlier timed than prior runs, with a 50% passage date of 5 days earlier. The one thing I did actually want to note is when we're talking about outmigration, we're talking about that last rather extreme El Nino we saw, we're going to be looking at for the entire spring and summer season, it'll really be those like 17, 18 years that are important to see kind of how they fared. For sockeye, it was a really rough year. Our Bonneville Passage was around 74,000, which is the lowest in the last 5 years, pretty significantly lower than the last couple years, and it was 27% of our preseason forecast. It was earlier timed a little bit than the 5-year average, with 3 days earlier on the 50% passage date. But as you can see by that bottom graph, it really was that plateau where we didn't experience a peak. That was a pretty tough. And then again, for sockeye, it'll be that 17, 18, where we're seeing some of those impacts of the 2015 outmigration. And for summer Chinook, our Bonneville Passage was 39,700, which is the lowest in the last 5 years, but it's really comparable to the last 3. And it was 97% of our preseason forecast, super normal timing, nothing really concerning. It's been low the last couple of years. And then again, that 17, 18 is where we would see the smolts that were out migrating during the last extreme event come back. Moving to fall. I wanted to start by showing I guess by addressing we're still in fall season. We're really early in fall season. We're I think 18, 19 days in at this point. So there's not a lot we can say, but I'm going to provide as best update as I can. I did want to start by kind of looking through what those smolts that were out migrating during the last event and acknowledge. So coho would be, we'd see the return. There's pretty variant age structures for most fish other than coho. So we would see that 2016 would be kind of when we were starting to see those smolts return. For fall Chinook, it would be generally between 2017 to 2019, which we do see a bit of a dip occurring there. And for steelhead, it would be 2017 to 2018 as well. So just move to that. For what we know so far. So upriver summer steelhead, our in-season projections have ACE index steelhead coming in much lower than predicted. The technical advisory committee did just do a downgrade. Yeah, so pretty tough this year. And it's too early to know for B index, but it's not looking great either. For fall Chinook, our ocean and in-river CPUE is really high. And our counts to Bonneville are encouraging, but it is still extremely early in our run, so we're not quite sure. It could be an early run, but everything is rather encouraging so far. For coho, our early catches are encouraging, but they're not always a great predictor of abundance. And then early counts to Bonneville are also encouraging, but there is a large lower river component that exists as well. So we don't know much. For fall Chinook and coho, it's seemingly encouraging. what we do know, but for summer steelhead, it's not looking as rosy. And then the forecast that we had for them are in the parentheses. So main points of concern that I just kind of want everyone to be thinking about as we're kind of moving forward into the next year. Both smolt outmigration and marine survival are huge components of how many fish are returning to us. Smolt outmigration is really impacted by flows and water temperature. And then obviously once they get into the marine environment, hot water can also really negatively impact them in that way. And, impact systems in general. We also have concerns about fecundity and condition. During the prior extreme event, the returning fish that outmigrated during that event had some smaller body size and some fecundity issues. So we're really concerned about that as well moving forward. In river, we're worried about in-river spawning, changes to run timing and die-off. So hot water is never good for us. That can cause a lot of systemic issues that we are keeping an eye on. And an important thing to kind of address, stocks are already generally lower than we saw in 2015 and the years preceding it. So we're generally starting off in a worse spot than we were. So that's kind of an important component. I think I hit my max. But other Washington sockeye stocks. Other stocks aren't doing great either. Oops, sorry, that's supposed to be stocks, not points of concern. For Baker Lake, the in-season estimate is much lower than the preseason forecast, with 59,000 coming in as the prediction in season, with around 51,000 accounted for so far. Lake Washington, the preseason forecast was 32,862. And so far we've accounted for 31,152. So it's looking like Lake Washington may be fine-ish, but Baker Lake's having a much lower season than they previously expected. Thank you. If you have any questions, please feel free to email me. I have a wonderful team, and I'm sure if I can't answer it, we can get someone else who. Thanks.
So moving along with the third presentation, sorry. Focusing primarily on Fraser River sockeye, because that's my own area of expertise, but rounding out the information a little bit more on what's going on this year with sockeye returns by also providing in-season run size estimates for Nass, Skeena, and Barkley Sound. So just looking first at the Nass River, we had a preseason forecast of 435,000 and an in-season estimate of 358,000. For the Skeena River, their in-season run size estimate at the moment look very good in comparison to the forecast, 2.1 million instead of the 1.5 million. For Barkley Sound, also, it looks like a forecast is exceeded, 900,000 instead of 750,000. Then moving on to Fraser sockeye, and there I want to highlight that we're talking about 27 different stocks, but for this presentation, it's combined into 4 different management groups, starting with Early Stewart. There, our preseason forecast was for 63,000, and we currently have an in-season run size estimate of 46,000. Unfortunately, news starts getting worse from there because for early summer run, we had a preseason forecast of 1.2 million, and our current in-season run size estimate is 250,000. The next one, we're still very much in the throes of in-season assessment, so I just want to highlight that the following estimates for summer run and late run, they're accurate as of yesterday, but for summer run, we have a preseason forecast of 4.3 million, and our current in-season run size estimate is for 2.2 million. And then finally, for the late run sockeye, we had a pre-season forecast of 2.1 million, and currently our in-season run size estimate is just for 1 million. So that brings our total Fraser sockeye estimate to 3.5 million compared to the 7.7 million that was forecasted pre-season. This is a very disappointing results for Fraser sockeye, especially taking into consideration that just four cycles previously, in 2010, we still had a record return of 28 million, and currently we're down to 3.5 million. At this point, it's still too early. Again, since we're still in the throes of in-season assessment to figure out what is the main cause of the low return. But I also want to highlight the variability in what we've seen over the last few years. I mean, last year we had a forecast of 3 million and we saw a return of 9 million for Fraser River sockeye. So overall, there's a lot of variability in the estimates, and it's quite challenging to predict or generate reliable forecast. So I also want to then perhaps put things in perspective. At this point, we don't think that the 2026 El Nino has had an impact on these returns. It's still too early for that. But then the question still remains, what do we expect the impact to be of the 2026 El Nino, and to what extent will that impact future return? In order to evaluate that, we're looking back at our historical time series of marine survival. So this figure shows you the marine survival going back to 1957. And on the y-axis, you have H4 recruits per smolts. And overall, you see quite a lot of variability in the yearly estimates, but generally, marine survival tended to be higher in the earlier part of the time series compared to the later part of the time series. Now we can overlay on these annual return estimates El Nino years, which years we expected to be impacting the returns, and the most reliable or most plausible hypothesis that especially the outmigrating smolts are impacted by El Nino. So if we assume a 2-year offset between the El Nino year and the return year, we can overlay publicly available information on El Nino years, which are all displayed in red on this figure. And then in blue, you can see La Nina years. And then in purple are the kind of neutral years. And then especially in the early part of the time series, you see a few years, El Nino years, or years where the returns may have been impacted by El Nino conditions, where marine survival in general has been low in comparison to the surrounding years. But then you also have a few years in that earlier part of the time series where the marine survival has been much better. However, if you look at the latter half of this time series, there doesn't seem to be the same general indication of El Nino years resulting in overall lower marine survival compared to the other years. So it might be that in the latter part of this time series, there's a lot more going on that impacts overall marine survival, and that the signals are not as strong because of all the other factors that could impact marine survival. So then, thinking back about forecast and how difficult it is to forecast returns, this definitely causes a challenge. And we all are aware that generating forecast for not just Fraser sockeye, but for any salmon species or for any fish species for that matter is difficult. There's a lot of uncertainty involved. But one of the good things about sockeye and is that a lot of the data is publicly available. So while forecasting is hard, there's been a lot of efforts being made to make the data publicly available. And so if people have hypotheses about how El Nino or changes to impacts of El Nino are impacting future sockeye return and Pacific salmon returns for that matter, how they are impacting returns, like it's possible to test those hypotheses. So I will just mention a few resources that are publicly available that people can rely on or use to test those hypotheses. One thing I want to mention is the salmon price competition. It started in 2024, where different biologists, scientists, or research groups have been putting forward different forecast models and generating forecast estimate, and they've been evaluating how their forecast scores against each other. But it's not just about the competition, it's about the dialogue that creates, because these different groups have been having regular meetings and discussing the different methods, discussing sharing, code sharing, method descriptions, and comparing different methods. There have been collaborations between different groups. So I just want to highlight this open source repository of all that information that's available on GitHub, where if you do have your own hypothesis, it's worthwhile to go there, and there's a lot of publicly available data available there where you can test out your own hypothesis and also see description of methods that already have been tried and tested. And then I want to also highlight that the salmon price competition, so far it's focused on sockeye stocks, and it include, for example, several Bristol Bay stocks, Columbia River, and 5 Fraser sockeye salmon stocks. But there is a lot more data available. So if you want to test your hypothesis on the 27 Fraser sockeye stock recruit datasets that are publicly available, please go and visit the PSC website. And I think, I mean, overall, all of these resources that are available, it's important because especially when we are seeing unprecedented returns, unprecedented conditions, talking about just the marine timing, for example, this year for Fraser sockeye, it's still early days, but we're looking at extremely early timing for late run sockeye, earlier than the summer run sockeye, which is unprecedented because, I mean, traditionally we always assume that late run returns after summer run and not before, and that doesn't necessarily seem to hold. There is a consistent trend now in the data since 2019, and this year might even be more extreme in terms of indicating earlier timing. So when these unprecedented things starts popping up, it's important to test hypotheses, new hypotheses, and to work collaboratively and multidisciplinary to figure out what is going on and improve our understanding of what is going on. Thank you very much. I'll end with that.
Thank you, Catherine, and thank you, Shannon and Guillaume, for some exceptional presentations. We are going to shift into the facilitated or moderated question and answer period in a couple of minutes. So that will give the audience a chance to collect their thoughts and post their questions in the Q&A box, and we will reconvene at 2:48. Thank you. All right, so we are back and we have a few questions that have been posed in our Q&A. I encourage folks to add some more questions as well. So I will start. I'm going to be moderating with Diego Holmgren. So the first question, Shannon, is for you, and it has to do with Washington sockeye. So it's a two-part question. So the first question is any information on Columbia River water temperatures and impacts on disease and stress from catch and release? So that's the first part of the question.
Yeah. I wouldn't say we have any studies going on currently, but I can speak a little bit on what we know. The warmer the water, the higher the likelihood of stress and cortisol levels in fish will be with catch and release handle. There are ways to minimize it that we work really hard on. We don't have barbed hooks in the Columbia River. We work really hard to inform the public on when is maybe when high temperatures may impact fish more. But yeah, catch and release and handling fish during higher temperatures definitely increase the stress on them.
The second question comes from Gary Morishima. Catherine, do run size estimates include estimates of pre-spawning mortality? Are confidence intervals about the run size estimates higher during past El Niño events?
Okay, so when talking about the first part of the question, talking about preseason forecast, so for Fraser sockeye, instead of working with spawner numbers to generate the forecast, forecasters work with effective female spawners, so that already takes into account pre-spawn mortality. And then, like in terms of confidence intervals about run size estimate being higher during past El Nino events, I think for Fraser sockeye, I think it's like to what extent are our in-season run size estimates reliable, and to what extent are our prediction of what ends up reaching the spawning grounds reliable. I think there are two different components to that question. So because for Fraser sockeye, we in season we actively monitor both the run size and what we feel that is entering into the marine areas and then into the Fraser River. Our run size estimates there are not dependent on any El Nino events, but then we monitor very strongly what's going on within the Fraser River, both the discharge and the flow. The discharge and the temperature, and we adjust, or the panel, the Fraser River panel adjusts the spawning escapement targets as needed, depending on what is the potential probability of fish not making it to the spawning grounds because of higher temperatures or high discharge, or for that matter, low discharge. So there is more uncertainty definitely about what proportion of the run will make it to the spawning grounds, but we haven't relate that to specifically El Nino event because there is such intensive monitoring of the temperature, so we don't have to work with more general forecasted estimates. We actually monitor the river in various parts of the watershed.
Thank you, Catherine. So I'm going to pose a question for Guillaume, and then I'll turn it back over to Diego to ask the question, the second part question to Shannon about sockeye. So for Guillaume, in your presentation, one really fascinating plot was the postage stamp plots of temperature or precipitation anomalies during an El Nino years, from the strongest to the weakest El Ninos over the last half a century. And one of the observations was that in very strong El Nino years, you could have very high precipitation anomalies and very low. So mechanistically, can you explain that at all, or is it very difficult to forecast?
It's not a question of difficult to explain. It's a question of difficult to know what's going on, right? So I don't know if I know better than you. So we are talking, I think we have to remember here that we're talking about pretty distant linkages, right? We're talking about the tropical Pacific being warmer than normal, and somehow that feeding into what happens with the mid-latitude storm track, and that relating to the characteristics of the storms in a way that affects how that manifests in terms of precipitation on the Northwest topography, right? So a lot of things can happen. Also, the other thing to remember is on a winter by winter scale, even though, we're well known for our rain, right? We don't get 1,000 storms, right? We get like 20. And so you're small sample size, you're subject to noise, right? So I think that's a big part of the explanation. What I will say, and part of the reason that I think that there's a decent, well, I'll say the limits of my physical understanding notwithstanding, I think there's a reasonable physical explanation for it being drier during El Niños and wetter during La Niñas in the sense that we tend to have, uh, broad brush, we tend to have more westerly kind of angle attacks for the storms in La Niñas, and more southwesterly during El Niños. And that changes, like what the characteristics of the storm were in terms of temperature in particular, right? We're drawn from the subtropics versus the mid-latitudes. And that makes sense from a temperature standpoint, but again, not so clear in terms of precipitation amount, right? Because the atmospheric rivers are often more southwest. Um, so I guess that's a long-winded way of saying like it's it's not so simple to link those two, and so uh, it makes sense to me that it wouldn't be a clear signal. I don't know if that's helpful.
Thank you. It's an interesting observation for sure.
Yeah.
Going back to Fraser sockeye, a question for Catherine from Gary. Catherine, the Sholko graph shows 4 years old return rates, but it was not clear if this include pre-spawning mortality.
No, it does not include pre-spawn mortality because we're looking at the number of returns to both Johnson Strait and Juan de Fuca Strait, so even before they end up on the spawning grounds.
Excellent. Thank you.
All right, so I will go back to Shannon. So this is the second part of Gary's question to you, Shannon. So when you were presenting information on Lake Washington sockeye, where the returns are, approximately 30,000 in 2026, the escapement goal for this stock, which was historically very, very abundant, is 350,000 fish. So this, that 30,000 return is less than 10% of the escapement goal, and it has been very low in the recent decade or so. So Gary's question is, how is the Columbia River sockeye, the Wenatchee stock, doing relative to its escapement goal? So it's there was like a 70% decline in returns in 2026, but do you know what that looks like in terms of its escapement goal?
Yeah. I want to first say Matthew Bogard is listening, and immediately once I said it's doing fine compared to forecast, messaged me and said, I do want to acknowledge it's not doing great. We do want to acknowledge Lake Washington had a rough year. So shout out to Matt. As far as the Columbia River sockeye, our USV organ escapement goal is 65,000 to Priest Rapids Dam, which we did just hit this year. So we did achieve our escapement goals by the skin of our teeth. But yeah, it was looking pretty touch or go there, but we did achieve it. And then there are some Okanagan up to Canada escapement goals that we do not quite know yet. Still a little bit of time left to figure those out. Yeah, thanks.
We are going back to the Fraser sockeye. A question from Kyle Adix. Any ideas what would cause the apparent earlier return of late run sockeye relative to summer run sockeye in the Fraser? Are we seeing timing shifts in sockeye in watersheds outside the Fraser?
Yeah, that's a good question. I mean, in terms of what is causing it, I mean, the one hypothesis could be that they're just going to other parts of the ocean. I mean, there's already this hypothesis that if the timing is earlier, then the fish are migrating more through Juan de Fuca Strait versus Johnson Strait. If the timing is later, they're migrating more through Johnson Strait. So the fact that we're also seeing really, really low diversion this year kind of again emphasizes that earlier timing, and then perhaps like they're just in different areas of the ocean, perhaps because of changing conditions there. To what extent it's seen outside of the Fraser, I cannot answer that, but I mean, we're also seeing it for Fraser pinks. I mean, Fraser pinks are also increasingly migrating earlier and yeah, causing more of an overlap with the migration of sockeye.
Thank you.
So I have a follow-up question for the fishy presenters. So Catherine and Shannon, maybe you could both respond to this question. This is a question posed by John Field. So you had both mentioned about the earlier run timing of sockeye and to some extent some spring Chinook in the Columbia River as well. And we've also learned from Dr. Mauger that it's early in the El Nino, super El Nino sort of cycle. So being, that's the case, is there evidence that the early arrival of El Nino conditions in 2026 could have affected returning adults in any of these systems? Are we just seeing sort of natural variability, or can we attribute anything to the El Ninos, similar to what we may have seen in past years, like lower body size, pre-spawn mortality, just lower body condition, any inkling that any of those impacts are being observed?
Shannon, you want to start off? Or?
Sure. I think this is a tough one. Because we're still kind of early on and we didn't have that many fisheries, a lot of the fishery questions are kind of tough to answer. I did want to note our jack returns were kind of low this year, so that's maybe something to consider. But body sizes were fine generally this year. Like I said, our water temperatures remain pretty low, so not that much concern about that. So yeah, unfortunately, a wait and see game a little bit for us.
And Catherine, for you, other than the timing?
Yeah, I mean, it's difficult to say, but I would say the most evidence we have of El Nino impacting returns is on the smolt out migration. And like, as I said, there's so many other things that seem to be impacting that there's in recent years no longer like the same signal that we saw in the past. So it's difficult to say to what extent this is contributing, and then it's still very early days. So at this point, I would say not yet.
We have another question from Gary. Dr. Mauger, any information on El Nino impacts on the upwelling and phytoplankton community composition?
I almost want to kick it back to Marisa for that question. I am not aware of that.
Do we have any other questions, Marisa?
So we have a few others. So just, I guess that Gary's question is a good segue to just remind the PSC family that our next seminar is going to be when we are all meeting in person in January, and there will be sort of similar to this, but more of the ocean condition updates from the Canada monitoring programs and the US monitoring programs that will directly address things like the upwelling, phytoplankton community compositions, smolt densities, ichthyoplankton, prey of juvenile salmon smolts out migrating. So just bear in mind, so when we all meet in January, that question will likely be addressed. I'm going to ask another question of Dr. Mauger. So one thing that has been a theme of these presentations has been sort of comparing and contrasting 2015 and 2026. And that was really the impetus of scheduling this seminar several months ago, is that, the forecasts were saying this was going to be a really strong El Nino. And looking back to 2015, we saw some really dramatic in-season observations. That one was the blob, so the development of the sea surface temperature anomalies in the North Pacific kind of combined with the Kelvin wave that was traveling up from the equator. And so the whole sort of Western Pacific was on fire, was like 2.5, 3 degrees warmer than average. And that really precipitated ecosystem impacts at multiple trophic levels. So we had, collapse of, cod, we had whale entanglements, we had, whole fisheries, just decimated, including crabs. And so, that was sort of what we kind of anticipated coming into 2026. So I suppose from an environmental climatology perspective, could you speak a little bit about sort of that lack of that strong blob in 2026 combined and maybe potential for those joining forces as we move into this stronger phase of the El Nino in the fall and winter?
Yeah, I mean, the short answer is that this is a great question, and the short answer is that we're talking about two entirely different things, right? We're talking about tropical sea surface temperature anomalies in the El Nino case, and we're talking about a warm blob or marine heat wave in our region in the 2015 case, right? So much more direct impacts, both in the marine conditions and terrestrial, with the blob, much more indirect impacts with El Nino, right? That's the big difference. I think it's not to say we can't have both at once, but like I said, and again, I think I could review, I'm not as familiar with the marine heat wave research as I would like to be, but what I understand of it is that there's not much of an indication that it is related to climate change. I'm not aware of a strong connection with ENSO. So I think it really is these things emerge. Sometimes we have some ability to predict them like under a year out. But they're not, it's a different thing altogether.
Thank you so much for that. So it looks like we have answered all of the questions that have been posed online. And with that, I would just like to once again thank all of the speakers for sharing their expertise and their observations from 2026. Like I said, when we scheduled this presentation, we were anticipating that things may be a lot more bleak than they actually are in season. So that's somewhat of a respite, but we're definitely going to be tracking sort of the progression of this El Nino and fisheries as we move into the fall and into, the following years when those out-migrating smolts are going to be returning as adults. So with that, I thank the audience for your attention. I thank the speakers, and I look forward to seeing everyone in person in January. Thank you so much.
Thank you.